So I want to talk about using PIN for attempting to analyze some malware. I've only actually been really using PIN in a hands-on mode for the last few months. I first started using it when I actually took one of the Exodus Intel training courses. And so they were talking about using it for vulnerability analysis and bug hunting. And some of the way they talked about stuff made me think, hey, I can actually apply this to what I do during the day for the most part, which is malware. This isn't new stuff. People have been doing this for a while. This is mostly just my experiences. And Gal Diskin gave a talk 2 or 3 years ago about a lot of use cases that some overlap with what I was talking about. Probably saw the slide yesterday. I still work at Arbor a day later. Reverse engineer malware. We do a lot of DDoS stuff. So this talk's just going to be about how I've been learning to use PIN and how I've been trying to apply it to what I do on a daily basis. This isn't an in-depth intro or anything like that, where I'm just going to sit here and go through the APIs. There's probably errors. I know I'm doing some things wrong, as you'll see later in my almost demos. So it's just definitely a learning experience, and hopefully some of the people who are in the audience that know a lot more about this stuff than I do can help me figure out what I'm doing wrong. And so the first thing is, when you're analyzing malware, you end up with a lot of challenges. These are some of them. One of the biggest challenges when I'm pulling in a binary is, even just before I even pick something to reverse, I have to figure out what's actually worth reversing from our corpus of malware. And then once I pick something, it's figuring out where to start. Which function's just CRUD, which function's actually interesting, which function which function contains the configuration, which function contains network communications, is there encryption, obfuscation, stuff like that. Or there's, hopefully there are static keys, but a lot of times, sometimes they'll randomly generate stuff. So if you actually want to look at network communications, you will actually have to pull it as one of these randomly generated keys out at runtime. And they also end up packing and encrypting or obfuscating code, so you have to go through steps of unpacking, decrypting, deobfuscating. And for the most part, we end up using a malware analysis sandbox to do a lot of that kind of work. And for the most part, it works really well. It gives us a lot of what we need, and it'll give us nice memory dumps at certain places. Then sometimes we also have the problem of identification, just trying to figure out, did I reverse this before? Is this code that I know? Is this encryption function something that's known, or did they try to roll their own stupid little XOR type thing? Then also you end up with a bunch of anti-debug things if you're trying to run a scriptable debugger, anti-VM type stuff, and anti-malware sandbox, and sometimes also like some of the other desktop sandboxes like Sandboxy, where they would just try to detect it and run. Marta went over some of that kind of stuff yesterday. And obviously the communications, you rarely ever get symbols. I've been lucky enough to have some people use the Ming WGCC compiler on their malware families, and randomly they'll sell a binary that's not stripped. And so I have one binary that's not stripped that I find after I've been analyzing, then I can then actually use to propagate symbols across everything. And then when you're also running this stuff, typically they have, it's not like vulnerability analysis where, I didn't crash it, let me just restart it and just rerun my program. So you actually run this malware, and it will usually attempt to do things that you can't necessarily be assured that when you're running it again the second time, if on a non-clean machine, if it's going to operate exactly the same way. So you mess up, you have to reset your VM, restart over. So it tends to be a huge pain and one of the challenges. And so that's where I turn to dynamic binary instrumentation. It's not like scriptable debugging. You inject your instrumentation code into your existing program. You don't recompile it. You end up executing the target inside your DBI tools memory. There are, Rich mentioned them, Dynamo, Rio, Valgrind, and PIN. I'm focusing on PIN because that's what I've been using most. And it's definitely what I know the most about, even though I definitely don't know probably more than a lot of people here. So Pin is the instrumentation engine created by Intel. It has Linux, OS X, and Windows versions. You write pin tools in C and C++. Going to butcher his name, Jurian Bremer, who gave a talk here last year on the Cuckoo and Cuckoo Sandbox. He's the developer of that. He's developing a set of pin bindings called Pin with a Y that he has up on his GitHub account that he's attempting to expose the whole Pin API into Python. I'm not sure how far along he is with it, but it could potentially be interesting. But Pin already has an overhead, and I assume that will end up adding some more overhead just being in Python. There are two instrumentation modes, JIT and probe. I typically find that JIT's not great for malware because at times you have self-modifying code, so ends up not being the best choice. I tend to use probe. I try to use probe mode when I'm doing stuff, and it also has integrated IDA support for some of the recent versions. And so I'll actually demo using some of that later. So JIT mode is none of the original code's ever executed. It regenerates it and execute only the generated code, never the original code. But then probe mode will redirect flow to your function, and will inject your code into that function. Everything runs natively. You get better performance, but you also end up having some limitations. So just some other quick pin things before I start kind of talking about potential use cases. So you can insert calls at a basic block, at a routine, basic block start and end, a routine start and end, or just like every instruction. And the other important thing to remember if you're dealing with basic blocks is that pin basic blocks do not necessarily equate to IDA basic blocks. There are some weird differences in the way IDA will create stuff and the way pin will create stuff. But you also have the ability to completely replace a routine if you want to say, I want to replace send receive with my own send receive. I want to replace printf with my own printf or my own malloc. And it also has the ability it has remote debugger support. And then the IDA pin tool for tracing and debugging. So how can you use DBI for malware? It can definitely help. So I have an idea. I guess I didn't put the quotes here, but using taint tracing, but not in this traditional sense, but in another sense that I'll go over a little bit next. Using it for looking at some network communication analysis, just general run tracing, so you can kind of help figure out what's going on where, and hopefully figure out what you actually want to reverse, and then also unpacking. These are just some ideas that I've been kind of playing with. They're not necessarily completely feasible. They're all feasible to some degree. And then it's also just kind of repurposing, some stuff that's already been done for the vulnerability analysis, bug hunting, triage side to more of the malware side. And usually, the end goal when you're dealing with malware is just to get it to a unpacked, decrypted, unobfuscated state. So for me, I tend to enjoy static analysis. So getting it to that state so I can end up just loading it into IDA and just doing my own thing. So taint analysis in quotes. So suppose you get a response back from the C2 and it's encrypted, and if you actually were to taint that and actually see where anything from there is copied and touched, you could potentially ideally locate a decryption function and decrypted data, maybe encryption keys as well. Jonathan Salwan from Quarks Lab has posted a lot of stuff on his blog at shellstorm.org around the vulnerability side of this. I haven't seen much work targeted towards the malware side yet for this, and it's not something I've started on because I'm just trying to get some pin tools actually running more cleanly, simpler pin tools running more cleanly before I move to something like this. And then, the unpacking side is actually, there are a lot of packers exist out there that, we see every day. The Reversing Labs has a product called Titanium Core that actually works on quite a few unpackers, but it doesn't work on everything. And also, I haven't seen it support any of the cryptors out there either. But these things also aren't just used for malware. You have things like the miner that are used to protect, I think, Spotify, like Spotify's desktop app, just because they don't want you reversing it. Skype has its own, weird packing system. And so I started working on a simple UPX unpacker just so I could learn it, and it ended up being more complex than I actually realized it would be. And I ended up not being able to get it to a state where I could even, have a demo that would crash here, unfortunately. But so I know the SourceFire VRT just a couple months ago had a blog on using PIN for some unpacking stuff. Julian Bremer had a blog a couple years ago about using it. He has a PIN tool that I think still works that can unpack the Run PE packer. And then another name I will probably butcher, Joshan Koret. He has a blog on, and I have links to all these on the very last slide in the references. So if you want to go look at them later, he has a blog about using PIN to unpack the Linux version of Skype. And so he actually did some cool stuff. Because, it was just a nice example of a legitimate application that uses packing that he wanted to reverse. That it ended up being simple packing, but he was still able to do something pretty cool with it. So, like the first thing I'll actually kind of go over is the IDA Pro's PIN tool support. So they have their PIN tool. You can set some options on it where you have instructions hit or basic blocks hit. You can have it set into call mode. You can import and export these traces. So you can run it on, a VM that you have to reset. You can run it on there, export the trace, and load it into like your actual analysis VM where you don't want to run anything. And then, just using these traces, you can locate some interesting stuff. And one of the experiences I ended up having with this a lot was that because I believe it uses JIT mode, and when I tried to run some pack samples, it ended up crashing pretty early on. So and you can also record register values, and that was just some of the stuff I said. So this is the PIN tool running. Sorry. Yeah, okay, supposed to have video controls up here. I don't. So it actually ends up running for a while, and then so the previous one ran for a while, and then I actually scrolled through. I'll throw up like the little short demo video somewhere. This was a different one that was packed that actually will end up crashing pretty soon. But the first one I only had call tracing on. This one actually had basic block tracing with instruction logging and register value recording. That if this finishes soon, that yeah, okay, I'll skip that. So if you want to see the video, talk to me later. It's the little the video controls in the slides are not appearing, so I can't fast forward. So the second thing I started doing was just function replacement, and the stupid malware trick that is easily bypassable is debugger present. It's it always you can set it to just return false or true, whichever one you want. And for the purposes of my demo, I ended up just returning true because I was running my little test program without a debugger. And so here you see my replacement function, debugger not present. I throw a log message into a file, and you see highlighted in red where I'm creating a prototype for these debugger present function, which when you replace a function in PIN, that's what you have to do. And so you have to say what args it accepts. So when you replace it, it knows what to pass. And then I'm doing a replace in probe mode with my function up there. And so yeah. So yeah, this was a just highlighting what I just said. I can't fast forward this. I'm sorry. Yeah, and so here I actually end up setting it to true and then recompiling. Now I run it without, says there's no debugger. Then I run it with my pin tool, and I've told it that there's a debugger there, but so it was just more to learn the basic concept of just replacing a function, simply replacing a function that didn't have any arguments and had a simple return value. So the next thing that I started looking at was hooking network communications functions. This was mostly the idea came because we actually did this in the Exodus class, and so in there we were looking at send receive for some network protocols that we were fuzzing, and so I said, this would be great if I could actually dump this stuff in malware, because sometimes in PCAPs you get lots of noise on the wire. Sometimes if it's like something like HTTPS, if you hook internet read file, you can actually see the data after it's come back and been decrypted, which you necessarily wouldn't see if you ran in something in a sandbox where it's just going to give you a PCAP and it's just going to show you, encrypted HTTPS transactions. Then you could potentially use that to say, hey, I know where the return value is stored, so now potentially apply something like taint tracing to it. So the first thing I'll demo for this is just I'm actually locating internet read file. I'm hooking the first and last instruction of internet read file. I'm inserting a before and an after where I'm inserting my instrumentation code. I make a request to the REcon's HTTPS site, and then I show a dump of the data. It actually ended up being harder than I thought to do this. I ended up spending days of just dealing with crashes. So when I was hooking the after, every time I started hooking the after for just internet read file, it ended up crashing in my program. I don't know why. If you do, please let me know. It'd be good to know. So I ended up actually adding my dump into my before because I was running just a test program, and so I knew that I would actually be iterating through a loop. But unfortunately, I was never able to get this stable enough to actually run it with malware like I had wanted to. And so up here you'll see I'm making the before call, and internet read file has 4 arguments, and then I'm setting the function pointer to be the call to go to my before probed, and then I'm setting the after to go to my after probed and have it receive the return value. And so the before probe actually it grabs the pointer to the buffer that's passing internet read file, and I also grab a pointer to the number of bytes read, so I know how much to dump. And then the after just says, hey, if I actually have read bytes, then dump that out. So this is just the test program where I'm showing, I was just highlighting that it was actually making HTTPS requests. And then the output of that, since I was actually hooking it before and dumping it before it ever called, the first one was just all CDs. But then after that, I was actually dumping out the plain text data that was coming back. So, when you have malware that's trying to communicate over HTTPS, this could potentially end up being useful. And so since that didn't really work the way I wanted it to, the next thing I moved on to was what I call non-simple function replacement, because it was something I hadn't done before. So I just decided to say, I'm just going to replace the internet read file with my own routine. I'll actually call the original internet read file. I'll pass that in as a pointer and then call that, and then dump the data out. But then with this one, I actually ended up crashing. I actually was able to get the first packet when it returned to my test program, and it immediately crashed. So I was never able to actually fully dump it. But so you'll see up here where I'm doing the same thing as before, where I'm creating the prototype of the function. I'm doing the signature replacement, but then I'm also, instead of just the arguments passing to my replace function, I'm also passing the IARG orig func pointer, which is the function pointer to what I just replaced. And then in my other function, I actually, call the orig, what I call orig IRF, original internet read file, with all those arguments, and then dump the output. Yeah, so this video ends up being, unfortunately, I cannot fast forward and skip past what I just showed you in screenshots. So here's the pin tool running, and then you'll actually see it immediately after it says it read 4096 bytes, it crashes. But then I can actually go up here and look at the log file and see that I did indeed dump out at least the first 4096 bytes. And if anyone can help me figure out why it was actually crashing that soon, I'd be really interested to know. And so, what I want to keep working on with this stuff is basically increase the understanding that I have of PIN, and just expand these proof of concepts to actually have something to release to the public. Actually do the taint tracing. So I've actually started working on was an anti-VM, anti-debug type PIN tool, where it was a lot of the stuff that malware is known to check for, like a lot of it that emulates the PA fish tool and some other stuff I've encountered. Start hooking those registry calls, hook the username calls and the computer name calls to actually check to see if it's something. Check to see if it actually ends up being one of the names it's looking for, and then return something fake instead, and then actually try to work on incorporating this into our malware sandbox environment so we can end up adding some more flexibility. So just to wrap up, it can't replace a lot of the tools we have, but it's still pretty useful. And PIN, JIT, Packers, it's not happy. And the other thing is this stuff isn't designed to be detectable. And there's a talk here 2 years ago by some guys from Core where they actually showed some demos of how to detect PIN being attached to programs. And in most cases, scriptable debugging is still probably the best thing to do. And it can pretty much accomplish what I've done. And it's still what I use to do a lot of the work I do with malware. So I guess with that, I'll take any questions.